Okay, Passarians, we are talking about the graphs of inverse functions today and how they visually look. And it's not really too bad of a lesson, but we do want to understand what happens. So I think what I'm going to do is I'm just going to highlight what I think you should underline or highlight. This is probably the most important thing to know is that if the point AB is on the graph of f, the point BA is on the graph of the inverse, and vice versa. So that's what's important. And then the second important thing, and I'll use a different color, is that the inverse is a reflection of the graph in the line y equals x. So if you were to reflect the graph over the line y equals x, which is that dotted red line or pink line, you would get the graph of f inverse. And if you were to reflect the graph of f inverse over the line y equals x, you would get the graph of f. So basically, they are reflected over y equals x because the y and the x are swapped, right? So that means if we have 5, 2 on this graph, if we have 5, 2 on this graph, if this is 5, 2, what's a point on the other graph? 2, 5. Very good, very good. So this would be 2, 5. I'm making it up. It's not really 5, 2. I'm just making up random numbers. So that means that if we have, let's say we have a table even, right? We have x. Actually, no, that's not going to work. We're not going to do that. So if we had the point negative 1, 7, what would be the point on the inverse? 7, negative 1, exactly. Just switching them, basically, right? So inputs are outputs, outputs are inputs. What's the square root of 9? What's 3 squared? There you go. Those are inverse functions, square root and squared, right? Okay, cool. So what we're going to do is we're going to verify that these are inverses by kind of sketching them. So I'm just going to kind of like let it happen and not get into it too much. So what I'm going to do is I think I might shrink this down just a little bit so you can see it better. And what I'm going to show you is the following, that these two graphs we want to have as inverses. So again, what you're kind of circling is, are these inverses? We're verifying that, so I guess they're sort of telling you that they are. So what would happen is you'd graph this red one. Let's make this red and blue, okay? We'd graph the red one, and the red one would be down 3, and then up 2 over 1. That's this line right here. Okay, that's the red one. The blue one is this one right here. It's actually not even up 3. I guess if you distribute it, you'd get a half x plus 3 over 2. So this is at 1.5, roughly. Let me see how this is working. 2, 4, 6. Okay, that's pretty bizarre. 1.5, and then we go up 1 over 2. So we go up 1 over 2. It'd be kind of a weird way of looking at it because it's kind of hitting on really odd angles, I guess. The other way to look at this is like if you did this in point slope, it'd be like y minus 0 equals a half x plus 3. So that means negative 3 comma 0 is on there. So negative 3 comma 0 is on that graph. I don't know if that landed or not, but point slope. The point is in the equation. Negative 3, 0 is in the equation. So that's this graph. Do they look like they're folding over like a beautiful Valentine? How appropriate for this time of year. Do they look like you could fold them over and make a beautiful Valentine over that dotted pink line? Yeah. So we do think that they are inverses. And so what we're going to do is we're going to check a couple points. So we're going to say, hey, is this point on here? Yeah, it is. And is its buddy point, right? So this is negative 1, negative 5. This is negative 5, negative 1. So again, we see that that's a check. Good. Let's do one more. So they're saying further verify it by testing a few points. We'll take this one and this one. 1, negative 1. 1, negative 1. Negative 1, 1. Check, check. They tested 5 points. We tested 2. You see what I'm saying? I'm okay with you testing 2, because generally if you test 2, maybe even 3, you'll be fine. That's it. That's all really it is. It gets a little bit more intense, but not really too crazy. We're just kind of talking about concepts. Okay, so checkpoint. I would encourage you to pause the video and give this problem a shot. We want to verify graphically that f of x equals 4x minus 1 and g of x equals 1/4 parentheses x plus 1 are inverses of each other. So that is our goal. So pause the video and give this problem a shot. All right, so hopefully you paused the video and tried this. What I'm going to do is I'm just going to kind of take this and I'm going to go down 1, up 4/1, right? And I see that there's kind of a line looking like this, basically. And then I'll take this one. I don't really love it, but the way that I look at that is I look at that as y minus 0 equals 1/4 x plus 1. And that tells me that negative 1 comma 0 is a point. So I'm going to go negative 1 comma 0. And then I'm just going to do a fourth. 1/4, 1/4, 1/4, 1/4. So thank you, point slope, because the y-intercept was wicked ugly on the blue one. The y-intercept was just weird. The question becomes, do they intersect here on this dotted line? Do they intersect, or sorry, reflect over this dotted line? That's the hope. I think I got it. They look like they do, right? But you could be thrown off. You never know. So we need to test a couple points. So let's pick a point. Let's go with this one. 2, 4, 6, 7. Oh, I don't even think that's right, is it? Let's see. Up 1/4, up 1/4. Yeah, I think it is. It's 7, 2. This point right here should be 7, 2. Let's make sure it makes sense. 7 in here. I don't love it. Let me count this again. 2, 3. Okay, let's see. No, this is not a good point. It's not a good point. Because remember, we were in this really weird place. Let's see, 1/4, 1/4, 7, 2. It should be there. Okay, all right. Oh, maybe I am good. Maybe I am good. I don't like it though when I put in the 7 there. Oh, actually, I think I'm okay. All right. All right, I doubted myself, guys. Never should have doubted myself. Well, it's really when I put in 7, 2 to the blue, I wanted to make sure it worked, and I had 7/4. So I was getting weirded out by that. But if I just take 7 and add 1, that's 8. 8/4 is 2. So I think that 2, 7 should be a problem. So 2, 3, 6, 7 right here. 2, 7. And 2, 7 did work, so that's our first check. Check, check. Now we'll pick orange. We'll pick another one. I guess we'll pick 3, 1. 3, 1. And 1, 3. This should be 1, 3. And they did work. And you could algebraically get that as well. Okay? So that's all you really need to do with that problem. I'm going to keep moving. In the interest of time, keep this video on the shorter side. Can't believe we're already at 8 minutes. Can you believe it? Wow. Time flies when you're doing precalculus. So verify graphically that these functions are inverses. I will kind of do this. Actually, I'm going to skip it. I'm just going to go right here and find it algebraically, because you kind of already did that one. So what we're going to do is we're going to find the inverse of this function. Do you have this on your sheet? Just want to double check, yeah? Okay, cool. Because I skipped around a little bit. Okay, so I'm going to give you the steps to this. So step 1, you're going to swap. You're going to swap x and y. Have you done this before? You're going to solve for oh, geez. So you're going to solve for y, and then you're going to write, basically f of the inverse type of thing. So basically you're going to swap them, so you're going to have x equals 5 minus y over 3y plus 2. A couple ways you could go about it, but your goal is to get y alone. I would multiply the denominator, so that's going to get me x times 3y plus 2 equals 5 minus y. I want to get everything, like all the y's to the left and everything else to the side, so I'm going to do 3xy plus 2x equals 5 minus y. And I'm going to add the y to both sides. So I'm going to have 3xy, just trust me with this algebra for a minute, equals 5 minus 2x. Okay. So all I did was grouped all the y's to the left and everything else to the right. Now I'm going to factor out a y because I can take a y out and then divide by 3x plus 1, and I'll have my final answer. So if I divide both sides by that factor, which is 3x plus 1, 3x plus 1, we will have verified this. So our inverse function is actually this. All we did was swap x and y and solve. There is definitely a little bit of like worries about that. I do want to make one more thing clear. This x right here, this x and this x, they are not the same as this x and this x. They are not in any way the same. Okay. What really should have happened is this should have been like x1 and that should have been like x2 or something. But those x's on the top left are in no way connected to the x's in the top right, except for maybe the flipping thing. They're actually the y's, believe it or not. These x's are y's of that. I know it's kind of blowing your mind a little bit, but you'll get there. So that's it. We found the inverse. That's how we find the inverse algebraically. So I'll have you pause the video and give this problem a try. Find the inverse of this following those steps. And once you finish that, we'll see you in the next video. But let me see if I can get you the answer real quick. Okay, so what you will do is hopefully you'll come up with x cubed minus 10. That should be the inverse function. You could put the black function into the purple function to verify it again if you wanted to be sure, or you could put the purple function into the black function. But basically, you've done it. You've found an inverse function the official way, and you've done this with the graphs. You kind of have an idea of what the graphs are going to look like. So I will see you guys in the next video. Make sure you smash that like button, subscribe, tick the notification bell so you don't miss out on any of the videos and content that I have for you guys. We'll see you in the next video. Peace.